All right, this problem is going to be worth 15 points, so please up at the top put 15, so when you are done you can score yourself. All right, problem number 1, let g be a differentiable function such that g of 6 is equal to -1. The graph of g prime, the derivative of g is shown above. On the interval from -4 to 4, g prime is equal to 3 cosine of pi x over 4. Right, part A asks us to find the average rate of change of g prime on the interval -4 to 6. Give an exact answer. Average rate of change, we know is just simply slope y2 minus y1 over x2 minus x1. So if I'm looking for g prime on that interval, we'll be doing g prime of 6 minus g prime of -4 over 6 minus -4. All right, and then g prime of 6, we are just going to look up 6 on the graph, and 6 on the graph is, because this is g prime, is 1, and then minus g prime of -4, 1, 2, 3 is shown at -3 over g, that's going to be 10. So this is going to be 4 over 10, which is a fine answer, or you could put it as 2/5. You are going to simply just get 1 point for that problem. Alrighty, part B, find the average rate of change of g. So once again, we know average rate of change is just a slope. So we'll be using the slope formula, g of 6 minus g of -4 over 6 minus -4. Fortunately, they did tell us what g of 6 is. It is -1. Okay, finding g of -4 is going to be a little different, so we're going to go back to what we usually do for these types of problems. To find, if we know g of 6 and we're looking for g of -4, we're going to set up the fundamental theorem of calculus. We're going to go from -4 to 6 of g prime. That will give us g of 6 minus g of -4. Okay, so to get the integral from -4 to 6 of g prime, we're going to be finding the area under the curve from -4 all the way till I get to 6, which is going to be right there. Okay, so oops, that as well. Okay, I notice we could do a couple different things here, but what I do notice is because of the symmetry of the graph of g prime, these two areas are going to cancel out with those two areas, so this area is just going to end up being 0. If you weren't sure about that, the way that I actually first started the problem, I went from -4 to 4 of g prime, and then I added it to go from 4 to 6 of g prime. And when you use, if you type this in Math 9 using this as your g prime, you do end up getting 0. Okay, and then we need to go from 4 to 6, so this is going to be 1/2. Once again, this is going to be at 5.5. So the base of this triangle is going to be 1.5 or 3/2, and then the height is going to be 1, 2, 3. So this is going to be 9/4. It is underneath the x-axis, so it's actually going to be -9/4. And then this one right here is just going to be 1/2 times just 1/2, and then the height is going to be 1, so that's going to be 1/4. So -9/4 plus 1/4 is going to be the integral from 4 to 6 of g prime, and that equals -2. So then if we continue just setting up this problem, okay, I knew that g of 6, they told me it was -1. So then if I add 1 to both sides, I'm going to get -1 is equal to g of -4, negative g of -4, excuse me. And so g of -4 will equal 1. So now I'm going to come over here. It's going to be -1. So this is going to be -2 over 10. Or if you would like to reduce it to -1/5, you could do that as well. This one was actually worth 2 points this time. So if you did something with an integral, you're going to get a point for that. And then if you were able to get the right answer, you're going to get a point for that. So this one was out of 2 points this time. Okay, part C, write an equation of the line tangent to the graph of g at x equals 2. So please remember that we need the slope and we need a point. And if we're at x equals 2, we want to find the slope of g. So we're going to be finding g prime of 2. So to get g prime of 2, this is g prime. So at 2, the slope is equal to 0. And then to get my point, I know it's going to be 2 comma something. To get that y value, it's actually just going to be g of 2. And to get g of 2, we are going to get to use the same process that we did in part A, which was to go from 2 to 6 of g prime is going to equal g of 6 minus g of 2. The integral from 2 to 6 was, if I go from 2 to 6, it's this plus this plus this. So if you do that, trying to look up what I did here. I broke it up because from 2 to 4, there's an equation for this. It's this right here. So I broke it up to go from 2 to 4 of G prime, and then I went from 4 to 6 of G prime. So 2 to 4 of G prime, if you type that in your calculator, you can use Math 9. I ended up getting negative 3.81972. I went 5 places just in case. And then for this next part, if I go from 4 to 6, did we do 4 to 6 in a different part? Let's see. No, I did not. Okay, yes, I did. 4 to 6, yep. So we got negative 2 when we did that. Okay, so then that's going to be negative 5.81972. All right, and that's going to equal G of 6 minus G of 2. We know that G of 6 is equal to negative 1. So then I'm going to add 1 to both sides, and I'm going to get G of 2 is equal, or negative G of 2 is equal to negative 4.81972. So G of 2 will equal positive 4.81972. So that is my Y value, which was 4.8. Now I'll round it to 2 places, so 4.820. Okay, so now when we write the equation of the tangent line, we're going to get Y minus the Y value equals mx minus the x value. So pretty much this is just going to be Y minus 4.820 equals 0, or Y equals 4.820. You could definitely have just left it like this if you wanted to, or you could work it down to the final answer. And on this one, we are going to get 2 points. We're going to get 1 point for finding the proper G value, and then we're going to get 1 point for the equation of the tangent line. So this was out of 2 points. All right, for part D, it asks us to find the absolute maximum value of G. So we know we're going to be looking for critical values, and we're going to evaluate at the endpoint. So I'm going to start at the endpoint, so G of negative 4 and G of 12. And then to get critical numbers, I'm going to be looking at G prime. Where does G prime equal 0? It's going to be at negative 2 and at 2 and at 5.5 and at 7. And I'm drawing a chart. There's a reason I am. I'll tell you in just a second. Negative, positive, negative, positive, positive. Okay, if I'm looking for an absolute maximum, I have so many to test. So if I don't have to test them all, that would be awesome. So if you look at negative 2, there would be a minimum. So there's no way that that's going to be a maximum. Same thing to get from 5.5 at 5.5, that would be a minimum. So there's no way it's a maximum. And then at 7, nothing's changing. So it could not be maximum either. So really the only candidates that I need to check are just 2. So those are the 3 that I am going to check. All right, G of negative 4 we found from part B, and that was equal to 1. And then G of 2 we found from part C, which was 4.820. And then G of 12, we get to go ahead and set it up like we were doing on the other one. So G 6 to 12 of G prime, which is going to equal G of 12 minus G of 6. All right, so we want to find the area under the curve from 6 to 12. Okay, this is a triangle, 1/2 times 1 times 1. So this is going to be 1/2. And then this is going to be 1/2 times 2 times 2, which is going to be 2. And then this area is going to be just a rectangle, 1, 2, 3, 4, 4 times 1, which is 4. So altogether that is going to be, what did I count wrong? 1, 2, 3. There's only 3 places. 3. So altogether that is going to equal 5.5. So we're going to get, so we'll have the area under the curve from 6 to 12 of G prime was 5.5. And then we'll get equals G of 12 minus G of 6, which you already know is negative 1. So it's going to do the plus. We're going to subtract 1. So G of 12 is going to equal 4 and 1/2. And this time it doesn't ask for the x value of the absolute max. It actually says what is the absolute max. So I'm going to say absolute max is equal to the biggest number that I see there is the 4.820. So that would be my answer for that one. We are going to get 3 points on this one. If we did figure out that x equals 2 as a candidate, we're going to get 1 point for doing that. If you did not disclude exclude all of those values, that's fine. You don't lose points or get points for them, so that's fine. If you also considered those endpoints, which is real important, you're going to get a point. And then if you were able to get the right answer of the 4.820, you got a third point. So that was worth 3 points. Okay, part E says to find the value of this limit or state that it does not exist. Generally, if a problem is set up like this, 98% of the time, it is going to be a L'Hopital. So that's definitely where we're going to be heading on this one. So the first thing that I want to do is just to try to type in 8 for each of them. So I'm going to have 2 minus the cube root of 8 over g of 8. Okay, this one's going to give me 2 minus 2, which is going to give me 0. Now I'm going to have to go find g of 8, just like we did on all those other problems. Yay. So I'm going to go 6 to 8 of g prime is equal to g of 8 minus g of 6. So we're going to find the area under the curve from 6 to 8. I notice they look the same. This is 1/2 times 1 times 1, so it's going to be 1/2. This one is also going to be 1/2. So the area under the curve is going to be 1. And then we'll get g of 8 minus g of 6. They already told me it was -1. I'm going to subtract 1 from both sides, and I get g of 8 is equal to 0. So notice I do get 0 over 0, which means I can use L'Hopital's rule. But remember, we do have to establish that. So I'm going to say since the limit as x approaches 8 of 2 minus the cube root of x is equal to 0, and the limit as x approaches 8 of g of x is equal to 0, we can use L'Hopital's rule. Okay, so then we can finish it from here. So now we're going to have the limit as x approaches 8. We're going to be taking the derivative of the numerator. The derivative of 2 would be 0. If you want to rewrite this as minus x to the 1/3, so when I take the derivative of it, it'll be -1/3 x to the -2/3, which can be rewritten as -1 over 3x to the 2/3. So the derivative of the numerator now will be -1 over 3x to the 2/3. And then in the denominator, the derivative of g to the x would be g to the prime x. Now I'm going to plug in 8. So I'm going to get -1 over 3, 8 to the 2/3, and then over g prime of 8. If you know how to do the numerator, you can go ahead, or you could type it in your calculator, either one. I know that that's going to end up giving me -1/12, and then g prime of 8, since this is g prime. If you look at 8, the y value at 8 is 1. So my answer, my limit, is going to be -1/12. So on this problem, you're going to get 2 points. If you correctly applied L'Hopital's rule with showing how you're going to get to apply it, you get a point. And then if you got your answer, you get a right point, a second point as well. All right, part F, it says, give the x coordinates of all points of inflection on the graph of g of x. Okay, one thing I just want to point out is all the other parts, there were just so many tricky parts in here, but this is just a nice straightforward one. If I want points of inflection, I need a g double prime chart. If I'm at g prime, I'm going to be looking at the slopes. So my slopes are positive till I get to 0. They are negative till I get to 4. They are positive till I get to 6. They are negative till I get to 7. They are positive till I get to 8. And then they go flat. All right, so if I'm looking at points of inflection, I'm looking where does the sign of g prime change? That's going to be at x equals 0, 4, 6, and 7. And they are x coordinates because g double prime changes sign. Alrighty, that was worth 1 point, but we got it. Good. Alrighty, G. For each of g double prime of 2 and g double prime of 9, find the exact value or explain why it does not exist. So g double prime of 2, basically again, g double prime, we're looking at the slope. So if I look at the slopes of 2, I'm looking at the slope right here at 2. So if I want the slope of g prime at 2, I'm basically wanting to take the derivative of the first derivative. So if I do math 8 on g prime, that will find me g double prime. And when I do that, let's see what answer I'm going to get. I got -2.356. All right, and then g double prime of 9. If I look at 9, I notice things are happening here. So the biggest thing is that if I'm looking for the slopes, they're not the same. So I'm going to say this does not exist. It's not even continuous. But the reason that I will say that, we'll just deal with our limit definition. The limit as x approaches 9 from the left of g prime of x is equal to 2. And the limit as x approaches 9 of g prime of x from the right side is equal to 1. And so the limit, and so I can just say, I really didn't even have to show that. I could just say because the limit as x approaches 9 from the left of g prime does not equal the limit as x approaches 9 from the right of g prime. Okay, that was worth 2 points. You got 1 point for finding g double prime of 2 and 1 for finding g double prime of 9. So that was worth 2. Alrighty, part 8. On what open intervals is the graph of g both decreasing and concave up? So decreasing has to do with g prime. Concave up has to do with g double prime. So I believe I made a g prime chart at one point in time to help myself out, and I'm going to make that again. -2, 2, 5.5, and 7. And my graph looked like negative, positive, negative, positive, positive. And because I'm below the x-axis, then above, then below, then above, then staying above the whole rest of the time. Okay, and then from there, I'm also going to make a g double prime chart, which was my slopes, which I also made one of this. So I'm just rewriting what I had already done. And then, okay, so this is going to be positive slopes, then negative, then positive slopes, then negative, then positive slopes, then zeroed out. Okay, so if I'm looking for where I'm decreasing and concave up, decreasing would be where g prime is negative, and concave up would be where g double prime is positive. So if I try to match where those are happening, I notice the first place they're happening is from where the interval starts, which would be at -4 until I get to -2. And then also, where else are we matching? Looks like starting at 4, but then I have to end at 5.5. And so those would be my places, and that would be because g double prime is negative, while g double prime is positive. All right, and I would get, all that work, I just got 1 point. So 1 point there. So hopefully now you have a score out of 15. Please make sure you write it on the front of your paper.